I'm going to record this meeting. So thanks for inviting me and giving me the chance to present my research. In the last decades, there have been many progresses in the research on Rett syndrome. From the proper recognition of the disease in the 1960s, another big result in 1999 has been the discovery of the gene associated to Rett, methyl-CpG binding protein 2. The discovery of the gene allowed the generation of disease models. And these models are mice mutant for MCP2 and show the same symptoms of the disease in humans: impaired movement, difficulty breathing, etc. The models have been used for studying the mechanism of the disease and for testing candidate treatment, both genetic treatments and pharmacologic treatments. These preclinical trials led to important improvement in the treatment for Rett syndrome, including the trials on trofinetide that has now passed phase 3 of clinical trials, and the gene therapy approach, where clinical trials are about to start. So during these years, we learned many things. Not all the success obtained in mouse models translated into success in patients. And this is quite common in biomedical research. Some compounds that reached even phase 3 of clinical trials in Rett syndrome did not pass, although several patients improved significantly with the treatment. Why is this so? We would expect that being Rett syndrome a disease associated to one single gene, the situation would be more homogeneous. Yet, we know that in Rett syndrome, there is a broad range of symptoms, and this can come with different severity. So each patient has a different prognosis and will respond differently to this treatment. The presence of different groups of patients is called patient stratification, and understanding the factors that distinguish different groups of patients will be very helpful to improve patients' management and identify the right treatment. This is similar to what happened for cancer. At the beginning, all the cancers were considered equal, and it was not clear why few remitted and the majority did not. But with time, it was discovered that there are different types of cancer, and now we know that some of them will have a very good chances to be treated. Also, understanding that there are different types of cancer improved the screening, the prognosis, and the patient's management. Also for Rett syndrome, not all the patients are equal. Now, what are the factors that distinguish different groups in Rett syndrome? For sure, the genetic mutation of MCP2 is an important player. A study in the US reported that mild mutations in MCP2 are associated to milder symptoms, while big mutations such as deletion of a central part of the MCP2 protein are usually associated to a severe clinical presentation. However, the genetic mutations are not sufficient to explain the variability in Rett syndrome. Also, epigenetics has a role. Females have 2 copies of the MCP2 gene, 1 on each X chromosome. For a natural program of our body, one of these X chromosomes is silenced, and if the healthy MCP2 copy is on the silent chromosome, the individual will likely have a pathology because the mutant, less functional MCP2 protein, is the one that is doing all the job. Vice versa, if the mutant copy is on the chromosome that is silenced, and the healthy copy is the one expressed, the subject will appear normal, and probably he or she will not even be screened for MCP2 mutations. So genetic and epigenetic factors are important, but also other factors such as diet, climate, immune system have an influence. And the variability of the symptoms paired with the rarity of the condition hampers the research on Rett syndrome, and it is probably the reason why the preclinical trials are more successful compared to the clinical studies. Mice models are more homogeneous. They have the same MCP2 mutation, they're growing in the same conditions, they eat the same food, and so on. So understanding even some of the principles of patient stratification could help us understanding Rett syndrome and planning new trials, so that more treatments can be available to different groups of patients. At the moment, one of the best methods to evaluate severity of symptoms is through questionnaires, where families or clinicians have to report the severity of symptoms in different areas, like sleep, breathing, movement, etc. This is the case for the Rett Syndrome Behavioral Questionnaire, RCBQ. However, it will be more objective to have non-invasive analysis, such as blood withdrawal, to measure the severity of symptoms. In a collaborative paper published in April 2022, my team, together with our collaborators, Professor Sahin, Professor Kaufman, and Professor Sur, found that measure of gene expression is indicative of the severity of breathing difficulties, and response to methasermin treatment is linked to expression of genes linked to immune function. This study was made only on 9 patients, but it suggests that there may be factors in blood that can quantify the severity of particular symptoms. In another study, we measured brain activity of patients enrolled in another safety study for methasermin, a candidate treatment that successfully passed the safety phase 1, but that failed to improve the primary outcomes of phase 2. We measured brain activity at different times of the study, including before the treatment, and we identified that a specific parameter of brain activity, coherence, which measures the synchronization of activity in the brain, is different in patients that improve with treatment versus patients that do not improve. We then built an algorithm that could predict the patients who would improve in response to treatment, and we found that this measure indeed matched the findings. This study also was performed on a limited number of patients, but it shows that also measure of brain activity can reveal information regarding different subgroups of patients. Altogether, this study suggests that it is possible to identify patients that distinguish different groups, identify factors that distinguish different groups of patients. The difference between patients with Rett syndrome are also present at the population level. Multiple studies in Brazil, Italy, Australia, and other countries reported demographic data on patients with Rett and show that there are differences across populations. Some countries, such as Australia and the USA, have many papers in this field. On this note, to characterize the Irish Rett population, in collaboration with the Rett Syndrome Association of Ireland, we collected demographic information from the caretakers of the patients. And we use a subset of questions used in the Rett Europe registry, and some families reviewed the questionnaire before distributing to the families of the association. We find that there are indeed differences between the Irish patients compared to other countries. It seems that the Irish patients have differences in the ability to walk and skeletal abnormalities. This can be due to limited sunlight, which affect the production of vitamin D, affecting bone structures. But this is just an hypothesis. Additional investigations are needed to confirm it. However, the most relevant problem in Ireland is the late age of diagnosis and the fact that the majority of the families are not aware of the genetic mutation carried by the patients. There are problems related to the local health policies, but they can affect the participation of patients in clinical trials and the proper management of the disorder. While informative, these papers can only compare the different populations in each country because the data are aggregated. There is a limited number of patients and different data are collected in different ways. But if we could find a way to pull all the data together and increase the number of patients, we could reduce the limits of the rarity and collect more information to understand and fight Rett syndrome. To this aim, we created a data sharing platform, DataRett. At the moment, this platform has data on Irish patients, but it has been designed to be expanded to include multiple data types and information from many countries. Our vision is that DataRett can serve patients and Rett researchers all around the world with information that can be input and retrieved by each member of the project. Based on our experience on other projects ongoing in Trinity College Dublin for other disorders like autism, schizophrenia, COVID-19, we plan to create a consortium where members will agree to the modality of data collection, data sharing, and each member will have a username and password that can be used to connect to DataRett to input and retrieve data. The data will regard both demographic, clinic, and research data, but no contact information will be retained by DataRett. Those information will stay with the local registries from each country or organization. And this means that DataRett will not compete with the existing registries, but it will integrate the data. This also means more protection from contact information. The most difficult part of this plan is to create the proper documents, data sharing agreements, patients' consent form, etc., to create the consortium and establish the data sharing process. Then the maintenance will have limited costs. The advantage for each member of the consortium is that each scientific publication using the data in DataRett will have as authors all the members of the consortium. The members of the consortium are not single patients, but designed members that will input and access the data. They can be members of associations or clinicians or scientists. This process will boost the research on Rett because the high number will give more power to the statistical analysis and, as shown in other disorders, lead to new discoveries. And finally, I'd like to thank the family associations, in particular the family associations of Ireland, the current members of my team, Kamal, Kira, and also Snow, who contributed to the analysis of the questionnaire, the past members in my team, and also my collaborators, Dr. Giorgio Pini, Honor Q, Dr. Kaufman, Dr. Sur, and Dr. Sahin. And of course, I thank the funding agencies and all of you for listening, and I'm ready to take questions.